Well, friends of mathematics, we're talking about Math 105, section 3.2, and we're going to talk about vertex form. And, just to recap, we had standard form, and that was y is equal to ax squared plus bx plus c. We had factored form, and that was y is equal to a x minus r1, x minus r2. And I want you to notice that those a values are exactly the same. And now we have vertex form. And this is y is equal to a x minus h squared plus k. These a's are all exactly the same. The a tells us that we're concave up if it's positive, concave down if it's negative. And when we talk about vertex form, our vertex, which means the high or low point, is at h comma k. So if we were going to make something like this, if here we have the point hk, and our piece went like so, here a is certainly going to be a negative value because we're concave down. And, there are ways of changing things from standard form into vertex form, and that's called completing the square. And that's a technique that we are not going to discuss at all. It's a technique that is no longer assessed in Math 105. Now, you might see it on the team homework, and that's fine. But for the most part, I want us to have this working understanding. And the first thing that we noticed about any quadratics is that the vertex point is an axis of symmetry, that I can fold a quadratic upon itself and get a reflection. And that's at the line x equals h. We also have this relationship that, and this is probably not necessary for us to know, that this value is negative b over 2a when something is in standard form. Just a way for us to find the x-coordinate of our vertex. Now, the takeaway that I want us to have here is if I give us any vertex, say negative 3 comma 7, there's an infinite number of quadratics that can go through this thing. Here I have a couple negative ones. Here I have a positive one. And let's pick this one right here in particular. Okay? Now, in order to talk about this general form, in general, I'm going to have y is equal to a x, and then it's x minus h, and so that's x minus a negative 3, so x plus 3 squared plus 7. You could also say that we took that quadratic, we shifted it to the left 3 units, and then up 7 units. But I need to figure out what a is, and so in order to do that, we're going to do exactly like we did with factored form. I'm going to pick some point not on the quadratic, so how about negative 5 comma 2? I'm going to use this in the only way I know how, where 2 is my output value. Negative 5 plus 3 squared, and then the 7. I'll subtract, so we'll have negative 5 is equal to a, and this seems like it's going to be 2, and square that, so we're going to have 4. And so negative 5/4 is a. And so what we can say is that our quadratic, the specific member of the family that we were talking about, is y is equal to negative 5/4 x plus 3 quantity squared plus 7. And, if I wanted to, I could blow this thing out, but really, this is a perfect solution to our problem.